Welcome to today's lesson. We are looking at chemistry kcse revision, that is reaction rates, reversible reactions, and the chemical equilibrium. I am Marida James, because it was National School. Subscribe my channel, watch, and share. So today we are looking at in this rates, reaction rates. This is a very important part in kcse. So I've analyzed some of the areas, the kcse areas, and this is from forward. And remember, this from forward in kcse normally has the highest percentage in paper 1, paper 2, and paper 3. So those students who are revising for kcse put a lot of emphasis in from forward, because it normally carries up to 70% of all the kcse questions, that is from paper 1 up to paper 3. So we are looking at the equilibrium. In this equilibrium, you need to understand that we are looking at the factors affecting the rate of the reaction. What will happen if the pressure will be increased? What will happen to the equilibrium? What will happen if the temperature in this case is increased or the temperature is decreased? Those are some of the things that we need to know. When answering this question on the factors affecting the rate of the reaction, a candidate is required to explain how the factors affect the rate of the reaction using the collision theory. In this equilibrium, when explaining equilibrium, a student is supposed to explain how the concentration, the pressure, and the temperature position on the equilibrium. What will happen in this case? If the temperature will be decreased, what will happen to the equilibrium? What will be the where the equilibrium will shift to? If the pressure will be decreased, what will happen? And if the concentration will be decreased, what will happen? So these are some of the things that we need to understand, to look at in the dynamic equilibrium. In a dynamic equilibrium, a dynamic equilibrium is a state of balance in which the rate of the forward reaction is equal to the rate of the backward reaction. In this case here, the concentration of the reactants and the products remains the same, and also the rate of the forward reaction and the backward reaction must be equal for us to have a dynamic equilibrium. So the first one, we have a reaction of bismuth, chloride, and water. In this reaction of bismuth, chloride, and water, bismuth chloride, it is colorless. When it reacts with water, it forms a white bismuth hypochlorite solid. So this one here, it is bismuth hypo. This one here, it is bismuth hypochlorite. So as you can see on the screen, there is here an equilibrium here. So there is an equilibrium. We don't know what that is. We have seen that equilibrium, there must be a balance here. So let us not call this one equilibrium, but we have a forward and then we have a backward reaction. What will happen here in this case? Explain what will happen if a few drops of the dilute hydrochloric acid is added to the mixture. If a dilute hydrochloric acid is added to the mixture, more of the white solid dissolves. More of the white solid, that is the bismuth hypochlorite, dissolves, because the addition of hydrochloric acid here, it favors the backward reaction. So when the backward reaction will be favored, it means that more of this bismuth hypochlorite dissolves. Suppose now here there is the addition of sodium chloride, sodium hydroxide. In the addition of sodium hydroxide here, the sodium hydroxide, this is the right, and then this one here is the left. This is the right, and then we have the left. So if sodium hydroxide will be added in the system here, if sodium hydroxide will be added in the system, equilibrium will shift to the right. So So the equilibrium will just normally shift to the right. In this case here, because addition of the sodium hydroxide in this case, it favors a forward reaction. If the forward reaction will be favored, it means now the equilibrium will just shift to the left. There is the formation of ammonia. Ammonia is formed in a Haber process. Reactions required in the preparation of ammonia, we have nitrogen and then we have hydrogen. Nitrogen is obtained from the fractional distillation of a liquidified air, and then we have hydrogen. We can either get hydrogen from the cracking of alkanes, or you can get it from the biogas. So in Haber process, for this reaction to take place, that is between nitrogen and hydrogen, there must be the optimum conditions in the Haber process. One of the optimum conditions in the Haber process is that there is a catalyst. A catalyst, and in this case, a catalyst is a finely divided iron catalyst which is enriched with aluminium. Aluminium here in this case, it is acting as a promoter. So another condition for this reaction to take place, it is a pressure of 200 to 500 atmosphere. And the reasons why we have the high pressure, it is to bring the molecules, that is nitrogen and hydrogen, to bring the molecules closer for the first reaction. And of course, another condition is a temperature. The temperature is between 400 and 500 degrees. When answering a question of the optimum condition in cases examination, a candidate is not required to give the range. So don't say a pressure of 200 to 500. No. Give a specific temperature, give a specific value which is in between 200 and 500. And also don't say a temperature of 400 to 500. Give a specific value between 400 and 500. The range is not required when answering the question in cases exam. So in this reaction here, there are several stages which takes place in the Haber process. There is of course the purification. Purification is whereby the dust particles and impurities are removed. And of course you need to know the reason why they are removed. It is they are removed to avoid the poisoning of the catalyst. Then the air they are compressed, that is nitrogen and hydrogen, they are compressed before they are taken to the heat exchanger and finally the catalytic chamber. So this reaction here normally takes place in the catalyst. So here we have those three optimum conditions. And as you can see here, the forward reaction is exothermic. So this is the forward reaction here. This is this is an exothermic reaction. So if to answer this question, you check whether the forward reaction is exothermic or the forward reaction is endothermic. And what do you need to understand here? That if the forward reaction is exothermic, as you can see here, in terms of temperature, when the temperature is increased, the backward reaction will be favored. When the temperature is increased, if the forward reaction is exothermic, the backward reaction is favored, and the backward reaction is in this case is endothermic. When the temperature is lowered, decrease in temperature will favor the forward reaction, which is exothermic. So in this case now, we are looking how is the yield of ammonia. How can we have the yield? What is the effect if the temperature will be increased in the yield of ammonia? If the temperature will be increased, there will be a lower yield of ammonia. In this case here, increase in temperature, it favors a backward reaction, which is in this case an endothermic reaction. So if water is added here to this system, you understand that ammonia is highly soluble in water. So what will happen here in the case if water will be added on this system here? What will happen here that water will observe a highly soluble ammonia and then it will remove it from the system. So this ammonia here will be removed from the system. then what will happen here? The equilibrium will just shift to the right. It will just shift to the right because the ammonia, all the ammonia here has been dissolved in water, it has been removed from the system, and therefore the reaction will shift to the right for us to have higher yield of more production of ammonia. Water absorbs high soluble ammonia, reducing this concentration from the system and therefore favoring the forward reaction. There is a formation of sulfur oxide. Sulfur oxide is normally formed when oxygen, sulfur oxide and oxygen, or we can say that is when sulfur oxide is oxidized to sulfur 6 oxide. So in this case here, this is from the Form 3 work and industrial process, that is the large-scale manufacture of sulfuric acid in a contact process. The optimum conditions for this reaction will take place, of course, as I said, in ammonia. We have a catalyst. The catalyst here, we have two types of them. That is vanadium 5 oxide, and then we have the platinum asbestos. Of these two catalysts, the vanadium 5 oxide is preferred to be used in the contact process because of two reasons. One, it is not expensive, and then it is not poisonous. So, on the other hand, the platinum asbestos may not be used in this reaction here. This is because it is expensive and then it can be easily poisoned. Another condition is a temperature, of course, which is ranging between 450 to 500. As I said earlier, in an examination, the candidate is not required to give the range. And then we have a pressure of 2 to 3 atmosphere. And the reason why we have that pressure of 2 to 3 atmosphere is to bring the molecules of oxygen and sulfur close for a reaction. So in this case here now, there are several factors which can affect this rate of reaction. One of it is the pressure can have the effect there. Increase or decrease in temperature can also have the effect there. Increase or decrease the concentration, for example, increasing the concentration of oxygen or the concentration of sulfur oxide here, it can also have the effect. So what will happen here is that the forward reaction is exothermic. When the forward reaction is exothermic, increase in temperature, it favors a backward reaction which is endothermic in that case here. So decrease in temperature here will favor a forward reaction which is exothermic. So if the temperature will be increased here, if the temperature will be decreased here, if the temperature will be decreased here, it will favor a forward reaction. It means now more of the sulfur 6 oxide will be produced. Lowering temperature will increase the yield of sulfur oxide now. Lowering the temperature, this one here, will increase the yield of sulfur 6 oxide. The forward reaction is favored since it is exothermic. The other ways of increasing the yield of sulfur oxide here, it is by increasing the pressure. Increasing pressure, it favors the side which has the fewer molecules. For instance, here, the number of the molecules on the reactant side is higher compared to the number or more reactant or more molecules on the reactant side compared to the product side. So here, this side, because of the low number of molecules, because of the lower molecules here, because of the fewer molecules, it can be affected. So it will be favored. And in this case here now, a forward reaction. The forward reaction will be favored because it has a fewer molecules. So the yield can be increased by increasing the pressure and also increasing the concentration. So increasing the pressure and also increasing the concentration. In this case, increasing the concentration, there is the increase of the sulfur oxide, and also there is the increase of oxygen. The other type of reaction is the reaction of hydrogen and carbon dioxide. The reaction of hydrogen and carbon dioxide, if you go to Form 1 work, you realize that this hydrogen is reacting as a reducing agent, whereby reducing this carbon dioxide to carbon monoxide, and then it is now oxidized to water. So this one here, from carbon dioxide to carbon monoxide, there is a reduction. From hydrogen to water, there is an oxidation, but we can discuss that one later. Now, when you look at this equilibrium here, there is the addition of sodium hydroxide. The addition of sodium hydroxide, equilibrium will shift to the left. The left is on this side. So what will happen here is sodium hydroxide will observe and remove the carbon dioxide from the system. And if that one will be removed now, it means now the equilibrium will just shift there, it will shift to the left because the backward reaction is favored. Increase in pressure in this equilibrium, it has no effect because there is no change in volume. Because here, the number of molecules we have on the reactant side. So on this side here, we have 5 molecules. So on this side here, we have 5 molecules because we have 2 hydrogen molecules here, 1 carbon, 2 oxygen here, so a total of 5. On the other side, we have 2 hydrogen, 1 oxygen on this side, we have 1 carbon, 1 oxygen, so a total of 5 molecules. So there is no change in volume. We have 5 molecules on the reactant side and the 5 molecules on the product side. So in this case here, increase in pressure, it has no effect since there is no change in volume. So we have an equilibrium between the dichromate and the chromate. So we have it here between the dichromate and the chromate. So the dichromate is here orange, as you can see. Then the chromate here is the chromate there. The chromate it is here. So what is happening here if there is the addition of potassium hydroxide? If there is the addition of potassium hydroxide here, the yellow color intensifies. So there is the yellow color intensifies. The yellow color intensifies because the addition of the potassium hydroxide introduces the hydroxide ions into the system, and therefore it will make the equilibrium to shift to the right because more of the hydroxide ions has been introduced into the system. We have also the concentrated sulfuric acid. If a few drops of a concentrated sulfuric acid is added here, a yellow color intensifies. So the yellow color also here intensifies. The yellow color intensifies. The concentrated sulfuric acid, it is a dehydrating agent. A dehydrating agent, it is that agent which has a property of removing water and water elements from a compound. So one example, it is this concentrated sulfuric acid, and also from our form to this one is classified an hygroscopic salt because it is able to observe or to remove water from a given compound, and then it forms a solution. So if the few drops of a concentrated sulfuric acid is added here in the system, the yellow color intensifies because the concentrated sulfuric acid removes water from the system and causes the equilibrium to shift towards the right to form more water molecules. So this is how that is an equilibrium between the dichromate and then we have the bromate ions. So if I can refer you back to organic chemistry, and this dichromate, it is the one which is used to test the presence of a double bond, the triple bond, or can test the presence of the test for the alkanols and alkanoic acids. So in these cases, likes of acidified potassium manganate 7, we have bromine water, and then we have the acidified potassium dichromate. These are the commonly reagents used to test the presence of the double bond, the triple bond in alkene and alkenes, and it can also be used to test for the presence of alkali, the OH in the alkali. So in some years back, the government of Kenya, the Ministry of Transport and Communication, it introduces an alcohol law, an alcohol law which was used to identify the alcohol content in a motorist, to identify the alcohol content in a driver. So what the alcohol law contains either, it was either containing the acidified potassium dichromate, which is orange, or it contains the acidified potassium permanganate, which is purple, or it contains bromine water. So what will happen if the blood content of a driver contains some alcohol? So it will normally decolorize the bromine water. It means now the yellow bromine water will change to colorless. The acidified potassium permanganate will change from purple to colorless, and also the acidified potassium dichromate will change from orange to green. So one of the disadvantages of that alcohol, if somebody is arrested on Friday, on Monday, by the time that person is being produced to court, somehow that alcohol it has disappeared from the head, and therefore in court normally the evidence is normally required. So that is some of the common areas where the cases examination can be set from. Make sure you revise well for those students who are doing the kcse this year. And also put a lot of emphasis in Form 4 work because it covers the largest percentage in kcse examination. Don't forget to subscribe my channel, watch and share.